Hi, this presentation continues the series on multiple regression and focuses on the testing of the statistical significance of individual predictors and the interpretation of the results. Researchers include predictors in models because they hypothesize that they will help to predict variance in Y. Thus, the null hypothesis concerning the effect of any predictor is that the predictor fails to make a unique contribution to the prediction of the criterion in the population. Note that the emphasis is on the word unique. This null will be tested using the t-statistic, and just as we have learned in bivariate regression, the t is computed by dividing our measure of effect size by standard error. Here, we will divide the partial regression coefficient by the standard error of the partial regression coefficient. When we test b, we are simultaneously testing all other statistics we discussed that are used to assess the importance of individual predictors. Thus, when the null hypothesis tests that b is equal to 0 in the population, it is simultaneously a test of the null hypothesis that the partial correlation coefficient in the population is 0, or that the semi-partial correlation coefficient in the population is equal to 0, and so on. We will use n minus 1 minus p degrees of freedom to define the critical value. Here is a table presented in SPSS of the results pertaining to the individual predictors in multiple regression. In this example, a multiple regression was conducted in which 3 quality of care indicators were used to predict 30-day rehospitalization rates for pneumonia in hospitals. This output is similar to the output in bivariate regression, but note that the partial correlation coefficient for each predictor is reported in the far right column. Let's read the table by looking at the first predictor, the percent of patients giving smoking cessation counseling in the hospital. The partial regression coefficient for this predictor is 0.958, and its standard error is equal to 0.174. When we divide b by the standard error of b, we obtain the t-statistic of 5.50. This will then be used to test the null hypothesis. Note that the standardized regression coefficient for this variable is 0.10, but that it is also the largest beta among the predictors. This variable also has the largest PR reported in the table. This suggests that this predictor is relatively more important than the other predictors in predicting unique variance in the criterion. Using our structure for reporting findings, let's interpret the finding for the smoking cessation predictor. The null hypothesis that the predictor fails to make a unique contribution to the prediction of variance in the criterion is rejected because the probability associated with the test statistic is less than alpha. Increases in smoking cessation counseling predict increases in rehospitalization rates. We found that 0.7% of the remaining variance in rehospitalization rates is uniquely predicted by smoking counseling after partialing the effects of other predictors in the model. Please note we have to square the PR to obtain the proportion of variance uniquely predicted by the predictor. Note also we use the term remaining variance instead of the term total variance to distinguish between the PR and the SR. Results for the other two predictors would proceed in a similar fashion. Note that the result for the predictor percent of patients given pneumonia vaccine during their hospitalization has a negative or inverse relationship with rehospitalization rates. Finally, note that the predictor percent of patients given the appropriate antibiotic within 4 hours of arriving at the hospital is not a significant predictor of unique variance in the criterion when the other two predictors are in the model. Here is the regression equation written using the findings from the table in the previous slide. I then took data from an actual hospital drawn at random and inserted the percent of compliance with each of the three predictors from this hospital in the regression equation. For example, this hospital reported 96% of their pneumonia patients received smoking counseling. As you can see, we predicted the readmission rate for pneumonia patients at this hospital was 18.51. The actual readmission rate for this hospital was 17.40. The residual, or the difference between the actual and the predicted score, was negative 1.11. You might remember that around the regression line, the sum of residuals of our errors in estimation will equal 0.